Hey guys, it's Mr. Peterson. Today we are starting on page 68. So we'll just start right here with number 3. So you'll see again that we have variables on both sides. So we want to get all the variables to the same side. So what I'm going to do is I'm going to subtract x from both sides. So these cancel, and I'm left with minus 1 equals, and these cancel, and I'm left with plus 1. So you'll know that negative 1 equals positive 1 makes absolutely no sense. So if you get a number equals some other number and it doesn't make a true statement, there is no solution to this problem. And if you think about it, if you take a number and you subtract one from it, you can't take that same number and add 1 to it and get the same answer. So that makes sense that there's no solution to this one. Let's jump over to number 4. In number 4, I'm going to get all those x's to the left side, so I'm going to add 5x to both sides. And I get 10x minus 10 equals 10. Then I'm going to add 10 to both sides. I get 10x equals 20. Divide by 10 on both sides. I'm going to run out of room here. So these cancel. I'm left with x equals 20 divided by 10 is 2. So this one has one solution. X can only be 2 to make this equation true. Okay, let's go to number 5. Alright, in number 5, we're going to have to distribute first. Okay, so I'm going to distribute this 4 to everything in there and this negative 6 to everything in there. So on this side I'll get 4m minus 12 equals, and then we have 10m minus 6m minus 12. So then our next step is to combine like terms on each side. So this side doesn't have anything I can combine, so I'm just going to have 4m minus 12 equals, and on this side I have this 10m and this negative 6m. When I combine those, I get 4m minus 12. And now I can start to solve. So I'm going to get all my m's on one side here. These cancel actually too. So I get negative 12 equals negative 12. If you get a number on one side equals that same number on the right side, there's infinitely many solutions. That means you could put pretty much any number in for m, and it will make this equation true. Alright, number 6. I'm going to distribute first this 4 to both of these. So I get 4x minus 16 equals 4x minus 16. Again, I'm going to get my x's on one side, get my numbers on the other. These cancel and these cancel. I get negative 16 equals negative 16. And then, since they're the same number on both sides, we have infinitely many solutions. Okay, let's go to number 7. So we're going to distribute first. So we get 2x minus 10 on this side, and we have 2x minus 5 on this side. I'm going to add 10 to both sides first. So these cancel. I'm left with 2x plus 5 equals 2x. Then I'm going to get rid of my x's on this side. So minus 2x minus 2x. So these cancel and these cancel. Now, when things cancel like that, I'm going to write over here again. When things cancel like that, it's not like there's nothing over here anymore and we're just left with 5. This turns into a 0. Okay? So again, if it makes a statement that's not true, there's no solution. And we can write it just like that. Number 8. And number 8's sort of like number 1, or number 3, sorry, the first one we did, where you can't take a number and subtract 4 from it and have it be that same number you started with. So I already know before I start this one that it's going to be a no solution, but let's just show our work for it. So I'm going to move all my x's to the left side. So I'm going to subtract 3x from both sides. These cancel and these cancel. I'm left with 0 equals -4, which makes no sense. It's a false statement, so that's a no solution as well. Alright, let's go to number 9. In number 9, we're going to do some distributing as well. So on this side, we'll have 10 plus 5v, and that equals, and then I'm just going to combine like terms as I go here. So I've got 5v plus 5. And you might already see something that looks like it won't work, so let's check it out. I'm going to subtract 5v from both sides. These cancel, I'm left with 10 equals, and these cancel, and I'm left with 5 equals 10. Doesn't make any sense. No solution. 10. We're going to distribute first. Remember, there's an imaginary 1 right there. Or invisible, I should say. So -1 times 4a is -4a, and -1 times +8 is -8. So I have 5 minus 4a minus 8. Now, you should see something interesting here as well. 5 minus 4a minus 8. 5 minus 4a minus 8. If they are the same on both sides, you'll always have infinitely many solutions. So let's just show how that works. So I'm going to add 4a to both sides. Oh, I didn't combine like terms, but that's okay. I'll just do it now. So 5 minus 8 is -3. 5 minus 8 is -3. Since it's the same number on both sides, we have infinitely many solutions. Alright, number 11. So the first thing we're going to do in number 11 is clear the fraction. So what I'm going to do is I'm going to multiply by 2. I'm going to multiply every term by 2. So these will cancel over here, and I'm going to be left with 2x plus 8 equals, and then x times 2 is 2x, and then 4 times 2 is 8. You'll notice, you'll notice that it is the same on both sides. 2x plus 8 equals 2x plus 8. So you should be able to tell already, but if you can't, let's go through it. So we're going to subtract 2x on both sides. Cancel, cancel. We're left with 8 equals 8. It is a true statement, so this has infinitely many. And then our last one, number 12, we're going to get rid of the fraction first. So to get rid of 1/3, we're going to multiply everything by 3. So multiply this by 3, this by 3, and this by 3. Okay? So these will cancel, and on the left side I'll be left with x minus 2 equals, and then these 3's will cancel, I'll be left with x, and these 3's will cancel, I'll be left with a minus 2. And you should see already, I'm going to subtract x from both sides, cancel, cancel, so we get -2 equals -2, which means we have infinitely many solutions. Alright, thanks guys.